Hi everyone, the question says, a revolving rifle fires 9mm bullets such that as they travel down the barrel of the rifle, their speed is given by this equation, where V is in meters per second and T is in seconds. So here you go, you have the first given information. The given information is a velocity equation. You have to write it down as the given. So far so good. Very nice. Continue reading. The acceleration of the bullet just as it leaves the barrel is 0. So we have a diagram of a rifle, everybody. The barrel is where? Right here. This entire length the bullet is traveling with this speed, with this velocity. And an important information says to you the acceleration of the bullet just as it leaves the barrel is 0. By the time the bullet arrives this ending point here, the acceleration you have to set to 0. So what did I do? I went to the second line and I wrote down one more given information. Acceleration of the bullet just as it leaves the barrel is 0. Now, what are we asked to determine? Determine the acceleration and position of the bullet as a function of time when the bullet is in the barrel. Okay, there we go. So, we are asked to determine the acceleration and the position. What did I tell you guys? I told you every time we are given an equation, you will either have to plug in or you will have to integrate and differentiate. You're going to determine the acceleration and you're going to determine the position. Scroll down. So first, I wanted to determine the acceleration. Acceleration is given by A. What is the acceleration? Acceleration is the derivative of velocity with respect to time, dv over dt. Are you following me? So the v here is given you where? Up in the given information, right there. So you write down the derivative of the velocity. What do you put down for the velocity? The given equation. Following me so far? Good. Now you have to refer to the table of derivatives. Which will be provided to you on the day of the exam. dt, let's just say we have a constant t raised to the n power. What's the solution to this derivative? So you have your variable. Why? Because the dt tells you you are differentiating with respect to time. It is raised to the n power and you have a constant in front of it, a coefficient in front of it. The n comes down. You end up having n times c, t to the n. Now you have to subtract 1 from n. So what have I done here? Let's go to the next line. In the next line, you will see here the 2 has come down. The 2 has come down here. You will see the 2 times whatever coefficient you had. And we had t, 2 minus 1, which will give you 1, which is why I did not even bother writing it. Moving on to the second term, how do you differentiate? You have 1 already. The 1 is going to come down here. 1, right? 2.65 times 10 to the 10. What happened to the t? It already had 1 exponent. Minus 1 is going to give you 0. Anything raised to the 0 power will give you 1. So that's going to be 1. Good. Moving to the next line, clean up everybody, and you have your acceleration. When I say clean up, just combine all the coefficients, multiply them, and so on. The last thing you want to do is have a look at this number. This number is 10.80. The coefficient is 10.80. What I would recommend you to do is make that number smaller than 10. So you move the decimal point 1 time. When you move the decimal point, this exponent is going to increase to 8. Okay, so put down your 8 if you have a larger number than 10 and the second term remains as it is. Now, how are you going to input these values into your WebAssign? follow what I'm doing, negative 1.080. Instead of doing times, you're gonna press star, the star key. It's shift plus 8, right? Times 10 to the, then you're gonna raise it. Raising is shift, and I forgot the key, but you have this symbol, times 10 to the 8, followed by the letter T plus 2.65. Again, if you want to do a multiplication, you will have to choose that star key and exponent, and then you just plug in 5. Okay? Good. So we're done with part A. Now that we are done with part A, we can move on to part B. I have to move fast, but you can always pause the video and you can go back and watch it again. We're not really at part B yet. We're just doing the second part of part A. Determine the velocity. Velocity, forgive me, we are already given the velocity. We determined the acceleration. Now we have to determine the position. Scroll down. The fundamental equation that relates the velocity to position is what? The change in velocity over time is equal to the velocity. So solving for what? We're solving for x here, but you cannot get it simply, so you have to do cross multiplication, right? Dx remains by itself. On the other side, you have v dt. You integrate both sides. When you integrate dx, you end up having delta x. And now you have to integrate the velocity with respect to time. You don't just integrate any velocity. You integrate the velocity that is given to you, that equation. You put the equation down. You integrate with respect to time. What next? You have to look at the table of integrals. Table of integrals. When you integrate a constant with respect to time, the solution is going to be the constant times the time. When you integrate a constant followed by t raised to any power dt, what's the solution going to be? C. T to the n plus 1, you're adding 1 to the exponent, and the denominator is going to be n plus 1, and the constant remains there. So using these two rules, now we're going to apply to the equation. You see here, the entire number is a coefficient. The entire number is a coefficient. Where is your variable? T squared and t raised to the first power. What do you do with t squared? You add 1 to the exponent divided by the total number of exponents. You add 1 to the exponent divided by the total number of exponents. So here we go. This is your position, everybody. Of course, I don't have a calculator with me, so I did not even bother doing this division here, but you should simplify it and go ahead and insert the answer. Now, you will see something here, the initial position. Let me see if we are given anything. You see, assume the position of the bullet at t equal to 0 is 0. This is telling you here the position, the initial position is 0. The initial position is 0. So what does that mean? This term here is 0. You get the idea? Very good. Now we can move on to part B. Ready? Part B is asking you a different question, and it's a tricky one. So let's see what it says. Determine the length of the time the bullet is accelerated. Determine the length of the time. What is the question is asking you? Is the question asking you length or the length of time? The question is asking you for time. The bullet is accelerated. If the question is referring to acceleration, you have to pull up the equation for acceleration. Following me? Determine the length of time the bullet is accelerated. So we have to pull the equation for acceleration, which I did here. Good. Now we are given a condition on the acceleration. What was that given condition? Remember, I told you to write these given information. Acceleration of the bullet, just as it leaves the barrel, is 0. there is a time at which the acceleration is 0. So the bullet is traveling down the barrel. Just as it hits that tip, the acceleration is 0. So if I pull my equation for acceleration, the moment I set it equal to 0, I have just determined this point in space. The starting time is 0. If I now set the acceleration to 0, I will determine the entire time the bullet is inside the barrel. Let me just go back here and show you. Go to the equation for acceleration. The equation for acceleration is all represented in time. Following me? Basically, we have two unknowns. The acceleration is changing, the time is changing. The moment you are setting the acceleration to 0, what did you determine? You're going to determine the time. The time for what? The time for the bullet to travel down, all the way down, until it hits this ending here and it's about to come out. So basically, the moment you set acceleration to 0, you are determining the total time the bullet is inside the barrel. Good. Which is why when you go to the next line, you will see acceleration set to 0, right? You rearrange and solve for the time. The time is 0.0245 seconds. Go ahead and do this calculation and you will just see my answer is consistent. Then moving to part C. What is the speed at which the bullet leaves the barrel? Right, what is the speed? Now you go to the velocity equation, the speed equation, at which the bullet leaves the barrel. Guys, in the previous part, we determined the total time the bullet is in the barrel. So you're just gonna take that total time, you're gonna plug it into the velocity equation. And then you're gonna get your velocity. What is the length of the barrel? The length of the barrel, how do you determine the length of the barrel, guys? We have to look at the position equation. So let me just scroll down to show you the work for part C. I pulled my velocity equation. I know the total time the bullet is inside the barrel, and I plug in that time, and I can solve for the velocity with which the bullet leaves the barrel. And finally, part D is asking you for the total length of the barrel. The total length of the barrel. While determining the length, what am I going to look at? Which equation am I going to look at? Velocity, acceleration, or position? Of course, I'm going to look at position because the position, the unit is meters, right? We are measuring length. How do I determine the length, everybody? Again, you know the total time is spent in the barrel. The moment you plug in the time, you will determine the length of the barrel. So scroll down, pull the position equation, plug in your total time, and you will get to the answer. I did not even bother doing calculation because the rest is just plugging in into your calculators. That is the end of this problem. Let me just zoom out if you want to take a picture, and we're done.